In this video, we're going to review our exponent rules. Now, this is something that you should have done in Algebra 1, but you might have forgotten some of the smaller details. So we're going to be reviewing these because it's going to come in handy for a lot of what we're doing in this chapter. Now, exponent rules, whenever you are dealing with monomials. Now, monomials are one term with no addition or subtraction between it, like 7 or 3x squared or just x. Those are monomials. And when you perform certain operations with monomials, they follow certain rules. For instance, the product rule is when you multiply monomials. So, for instance, if I had two numbers with the same base, but both raised to a certain exponent, in order to combine them, I would actually add the exponents. So, for example, if I had x squared times x to the 7th, I would get x to the 9th. The power rule is when you have some number raised to an exponent raised to another exponent. In this case, you're going to multiply your exponents. So, for example, if I had x to the 7th squared, I would get x to the 14th. Quotient rule is if I divide exponents. So, if I take two numbers with the same base, I would subtract the exponents to get the answer. So, for example, if I take x to the 7th divided by x squared, I'm going to get x to the 5th. Now, you don't want to have negative exponents. So what if on this one I had x squared over x to the 7th? Well, quotient rule says I'm going to get x to the negative 5. But anytime you have a number raised to a negative exponent, it can be written as its reciprocal. So 1 over that. So here, instead of having x to the negative 5th, I'm going to write it as 1 over x to the positive 5th. Now, let's say that you have an exponent of 0. Any number raised to the 0 power is going to be equal to 1. The only exception to this is 0 raised to the 0 power. That's an undefined number. So, for instance, if I had 2x to the 7th raised to the 0 power, well, 2 to the 0 power is 0, x to the 7th to the 0 power is still 0. This whole thing, I'm sorry, the whole thing is raised to the 0 power, so it's equal to 1. I think I said that wrong. So, let's look at some examples that use these rules. This first one, we are multiplying two monomials. So you are basically multiplying the similar types. So 5 and negative 7. I'm going to multiply that to get negative 35. Multiply by x's. X squared times x to the 6th. Well, product rule says we are going to add those exponents to get x to the 8th. Y cubed times y to the 4th gives me y to the 7th, because you add your exponents. Now, if there is more than one thing going on, for instance, this is raised to the 2nd power and we're multiplying, you still follow order of operations. And in order of operations, exponents come before multiplication. So I'm going to first raise that to the 2nd power. Now, I have to raise every piece to the second power. So for the first part, I'm going to have negative 2 squared. Well, that's negative 2 times negative 4, negative 2 times negative 2, which gives me positive 4. Now we've got numbers with exponents. So a cubed to the second power. Power rule says I will multiply those exponents, so I get a to the 6th. Now this b term, this right here, we don't see an exponent, but if there's not an exponent visible, the exponent's a 1. So 1 times 2 gives me 2. That's b squared. Now I'm not done with this one because I still have the other monomial. I still have to multiply. And now it's like our first example. Multiply the 4 and the 8. That gives me 32. A to the 6th times a to the first power. You add the exponents to get a to the 7th. And then b squared times b to the 9th is b to the 11th. Now the next problem, there's 2 parts as well. An order of operations says that the division comes before the subtraction. So we're going to start by dividing here. And again, you just take it one piece at a time. 54 divided by 3 gives me 18. It divides evenly, so there we go. X to the 6th divided by x squared. Quotient rule says I'm going to subtract, so 6 minus 2 gives me an exponent of 4. Y to the 4th divided by y gives me y to the 3rd, because again, there's an exponent of 1 here. 4 minus 1 gives me 3. Now, I'm bringing over this part here. When you are adding or subtracting, you can only add or subtract if your variables and the exponents of those variables are the same. In this case, they are. X to the 4th, y to the 3rd, same here. The difference is when you are adding or subtracting, you are not going to change your exponents. The only thing that changes is the coefficient, the number out front. So 18 minus 10 gives me 8, x to the 4th, y to the 3rd. Now I can only combine those, I can only subtract those because they have the same. So if I had, for instance, 2x squared y plus 2xy, I cannot combine those because those exponents are different. This is 2, this is a 1, you can't combine them. So you would just leave it like that. Now this last example, I haven't done any with negative exponents. This last example will include some negative exponents. Now you take it one piece at a time. So 15 divided by 24. Well, that's not going to divide evenly. So we're going to treat it like a fraction and reduce it. 15 and 24 are both divisible by 3. So divide by 3 and I get 5 over 8. Now you'll notice I extended the fraction bar to leave room for my x's and y's. So the x's, I have x to the 10th over x to the 12th. Well, when I do that, I'm going to get x to the negative 2, because you subtract the exponents. Now we're not going to be able to keep that because you don't want negative exponents in your answer. It's not simplified unless you get rid of that. Now let's do the y's first before we get to that part. So y to the 4th divided by y cubed just gives me y. Now, in order to completely simplify this, we have to move just this x term because that's the only one raised to a negative power. So my 5 and my y stay on the numerator, and I move my x to the positive 2 power to the bottom. Honestly, you can probably skip this step. If 10 minus 12 gives me negative 2, well, if you want to just go ahead, okay, that means I'm putting x squared on the bottom, you can do that. But if it helps you to see it, write it out. Okay, so I think I'm going to stop this for today, keep it short. I'll see you next time.